Hey everyone, Terry here. What we've done up to this point is we've talked about the theoretical component and all of the associated guidelines, recommendations, features, capabilities, and operational parameters that go into RIP, our Routing Information Protocol. So now it's time for us to spend the next consecutive series of videos looking at RIP from the point of view of the command line. Now what I want to do is I want to initially begin our conversations by doing basic RIP configurations. Now what we're going to find is that by following this method, we're going to have some issues in our topology with regard to how RIP is going to be representing certain prefixes. But before we delve into that, what I want to do is I want to highlight exactly what it is or what topology we're going to use to walk through our discussions using RIP. Now, what I have is I have a series of devices. I have R2, which is going to be connected to R3. I have Cat1, and I have Catalyst 2 in my topology. I'll go ahead and just draw those as squares so that we'll have the representation as far as our Layer 2 and Layer 3 devices. In the middle here I have R1, as well as having R4 and R5. Now each of these devices are going to be connected like so. So what we're going to find here is I'm going to have VLAN 23 here. I'm going to have VLAN 210 here. I will have 230 here. Connecting the switches, or the switch to Cat1 or R1, what I'll have here is I'm going to have 101, and I will have 201. I will have VLAN 204 here, and I will have VLAN 205 here, and I will have VLAN 45 here. So following the normal stricture that I've used in almost all of our demonstrations, I will just simply use the device names or some variation of the device name, whether it's a switch or a router, in order to be able to create a VLAN that we'll use in regards to setting up IP addresses. Again, what I'll use is I'll use 10.1. That combination of number dot the router device or the switch device's identity. Now in this case, what I'll have is 11. Cat1 will be .11. Cat2 will be .12, R2 will be .2, R3 will be .3, R4 will be .4, and likewise R5 will be .5. So what we need to do now is we need to start looking at exactly what goes into basic RIP configuration. And what I'm going to say, I'm going to specify version 2 config. Now, the thing that we need to recognize here is this version 2 is the protocol that's on the blueprint, and it's going to be version 2 that gives us the capability to be able to support variable length subnet masks, which means we're going to identify or advertise information about the prefix and its mask that's associated to any of our individual interfaces. Now, RIP is probably the most problematic routing protocol that we're going to deal with in the context of routing and switching version 5, and I personally still believe that it's there in the blueprint simply so Cisco can use it to introduce redistribution situations whereby we can lose information and then re-originate information into other areas or into other routing protocols, thereby having a greater possibility of generating loops in our environment. So I want to make certain that we have a firm understanding of what happens with regard to using RIP. Now what I'm going to do is I'm going to do my configuration on R1, R2, 3, 4, and 5, and Cat1 and Cat2. So let's take a look at what we have right now from the very beginning on R1. So show IP interface brief, exclude assigned addresses, and as we see, we have the interfaces that I was talking about. I have VLAN 101, VLAN 201, and I have a 172.16.1.1, which is going to be my loopback interface. So all of my loopbacks will begin with 117.172.16.x.x, where x.x is the device number. Now, if I want to run RIP on this device, all I do is router RIP. I need to specify version 2, and I'm going to leave it at that. We're not going to mess with anything with regard to summarization. We will talk about summarization in its own video portion of our RIP discussions. So right now I've enabled the process, but what I haven't done is I have not advertised any prefixes. So let's modify that. So what I'll come in here is I'm going to say network, and I'm going to advertise 10.0.0.0, and I'm also going to advertise network 172.16.0.0. Now, do show IP protocol is going to give me some information about this process that I just engaged. Notice I'm running RIP, and notice here I am sending and receiving version 2 on Fast Ethernet 00, and I'm sending and receiving version 2 on Ethernet 0/1. And also notice that I'm operating with my loopback. So I see here that I have all of my devices, all of my interfaces configured on R1. Now what I'm going to do is let's go through all of these devices very quickly and get everything advertised. So first of all, we'll cut over to R2. Oh, why did it do that? 1 second here. R2, config T, router RIP, version 2. Let's do this. Do show IP interface brief, exclude assigned addresses. These are the addresses that we need to advertise. So I'll just simply do 10.0 or 10.0.0.0. And I will do network 172.16.2.0.0. Well, let's go ahead and do the 2.2 because that'll allow me to illustrate a point. Do show run section router. And what we're going to see here is it took the 172.16.2.2 and it took it back down to its class full mask, which would be a /16, because this is a class B address. Now, recognizing this, again, do show IP protocols. I should see that I'm running RIP on every interface that I have configured. So I've got 02, 03, serial 20, and I also have the loopback where I made the configuration. So let's bounce over to the next device and do the same thing. Router RIP version 2, do show IP interface brief, E assigned, and I'm going to say network 10.0.0.0 and network 172.16.0.0. All right, with that being done, I'll go ahead and bounce over to 4, get it configured. Config T, router RIP version 2, network 10.0.0.0, network 172.16.0.0. Do show IP interface brief, exclude assigned addresses. That falls into the range that I'm looking for. Do show IP protocol. And I can see here I'm running an EIGRP process, and that's something we're going to talk about shortly, very soon, but not yet. Right now all we want to do is focus on RIP. On this device, notice now I have Ethernet 00, Ethernet 01. I've got my serial interface and I have my loopback. So everything should be good to go there. So let's bounce over to 5 and do the same thing. Router RIP version 2, network 10.0.0.0 and network 172.16.0.0. Do show IP protocols. And as we can see, we're running quite a bit of stuff on some of these devices. But on R5, what I want to do is I want to look at RIP. There it is. 0001, serial 20, which we don't have on our drawing. We have a loopback, and we also have this tunnel, because what we have in this topology is we have a DMVPN configuration. It's going to be the way that we can illustrate how our routing protocol is going to behave on a non-broadcast multi-access environment. Now, we've not enabled it yet. It's currently running on R5, and it's going to be connected to some other devices in our infrastructure that we're not talking about yet. But right now, all I want you to understand is that by doing the network command, setting up the version 2 configuration, what we've done is we now have RIP running on all of our routers, but we haven't configured our 2 switches. Now, in the confines of our switch config, what we're going to do is we're going to find that I have SVI interfaces. Show IP interface brief, exclude assigned addresses, and we'll see I have a loopback, and I have 3 interfaces, VLAN SVI interfaces, and what I want to do is I want to run a routing protocol on my switch. Well, the only difference between trying to run a routing protocol on a layer 3 capable switch versus a router is the fact that IP routing is not on by default on a Catalyst switch. So what I'm going to do is I'm going to say IP, where is it? IP routing, sorry. And I'm not going to specify a protocol, I'm just going to simply say IP routing. I was thinking about IPv6 there for just a minute. So when we look at IP routing, now I have the capability of coming in here and saying router RIP version 2, network 10.0.0.0, and network 172.16.0.0. All right, now let's do the same thing over on Cat2. IP routing, router RIP version 2, network 10.0.0.0, and network 172.16.0.0. Do show IP protocol. And we can see that we're running the interfaces that we outlined, our loopback, and we have our SVI interfaces running on Cat2. So with this being done, what I want to do is I want to look at R1 right now. Now in the context of R1, I should be learning about prefixes. So how do I know that I'm doing that? I can type show IP route, and it's going to give me every prefix that I'm learning, but I could also come in here and say show IP route RIP, and I can look specifically at the RIP prefixes that I'm learning. Now when we look at this, what we see here is I'm learning prefixes. So here's the prefix. Here is the next hop device that I would use to reach that destination. Here is the interface address that I'm using. And also notice I have my administrative distance, and I also have my metric, which, as we discussed in the theoretical conversations for RIP, actually turns out to be just basic hop count. Remember, RIP is a distance vector protocol. Even though RIP version 2 is slightly enhanced versus version 1 in that it supports variable length subnet masks, the idea is that it's going to be the most rudimentary and basic routing protocol that we have in our inventory to work with. Now what I want to do is I want to take a look at some of these other prefixes that we're learning. And the ones that I want to pay attention to here are, notice my 172.16.0.0, and it's telling me it's advertised as a /16. Well, if we keep in mind that by default, we said version 2, which means we support variable length subnet masks. But now what we need to do is pay attention to the default behavior of a protocol like RIP. Routing Information Protocol, by default, uses something called auto-summarization, which means it's going to summarize prefixes that it's learning as they cross boundaries. Now, what I want to do is I want to kind of expound on this concept and demonstrate just how problematic this could be by adding another device to our topology. Now what I want to do is I want to pretend that in our current topology we have another device. Let's say we have R22. Now R22 is a data center device. R22 is going to be located in an off-site data center. So what we'll do is we'll just bracket this, actually, one second here. We'll bracket this in dashes. So this is an off-site data center. Now what we're going to find is that the R22 is serially connected to R2 and R3 via 2/0, so it's S20 and S2/1. So this one's going to go to 2/0, this one will go up to 2/1 on R3. So let's enable these and make certain that everything is going to be up and operational. Now what I'm going to do is I'm going to go over to R22. Goodness gracious. Bear with me just one second here. R22. And let's see what's going on here. So do we have interfaces already configured or do we need to make them? Show IP interface brief, exclude assigned addresses. Notice I have interface 2/0, but I do not have an interface 2/1. So let's see what's going on. Oh, I'm on the wrong device. I need to be on R22. There we go. So R22 is that data center device that we were talking about. So it's a router in our data center. Show IP, interface brief, E assigned. And here we have the two addresses. The range is 222 and 223. So I'll go ahead and write these in just so that we don't have to reference this again. So this is going to be 222. This one is 223. All right, so now that we've got that, let's see what happens when we enable our routing protocol here. So config T, router, RIP, version 2, network 10.0.0.0. And we should be advertising prefixes. Now notice we did not have a loopback configured here. So let's go ahead and make one while we're here. We'll go ahead and advertise it. We'll say network 172.16.0.0. And what I'll do is I'll come up here and I will say interface LO0, IP address 172.16. And how best to do this. So we'll say 222.222. We'll advertise it, we'll run it as a /24. Show IP protocols. Let's see what's being advertised now. So we should have that one loopback and the two serial interfaces participating. Now the question is do I need to make any configuration on R2 and R3? Well, do show IP protocols tells me that I'm running it on my serial 2.0 interface here, and we have to take into account why that happens. It happened because there is no real granular or surgical approach to be able to enable RIP as a routing protocol to be running on interfaces because we have such a broad spectrum tool with regard to configuring RIP, i.e. everything is going to be advertised, or we use the network command using the class full boundary. Now what we need to understand here is that we're still advertising classless information provided we're no longer doing this idea of auto summarization, which we're going to talk about shortly. But right now what I want to do is I want to show, even with the basic configuration, it looks like things are going to be up and running, but the moment we start having this scenario where we have these 172.16.x.x interfaces that are participating in RIP and they're running their configuration or they're advertising their masks into the enterprise, what we're going to find here is that the system is going to receive erroneous information. And I want to be able to demonstrate that from R22. The idea now is that it should have had time to learn prefixes. So let's take a look at this. Show IP. Show IP route. RIP. And notice right now, I only have one prefix in my entire table to reach every 172.16.0.0 prefix. So my system also thinks that based on the fact that I have two entries here in my actual database, in my RIB, I'm going to be able to use load balancing to reach my destinations. So let's take a look at what would happen if I come up and I did a ping. So let's say ping 172.16, and what I want to do is I'm going to hit 5.5. And let's see if everything goes through and everything's working. Well, notice I don't have any reachability information whatsoever. Nothing's showing up here as being reachable. Well, maybe I forgot. Maybe I didn't. I have the wrong IP address. So while this is percolating, let's go over to R5 and take a look. Do show IP interface brief. Let's go ahead and just say exclude assigned addresses. Well, let's see. I've got 172.16.5.5. Is that the device that I pinged? 172.16.5.5. Now, what I want to pay attention to is if I come up here and say show IP route 172.16.5.5, and hit enter, it's going to tell me that I can reach that using R3 and using R2 out these two serial interfaces. Well, maybe the problem was R5 didn't know how to get back to R22. So let's take a look at that. Do I have those prefixes? So show IP route RIP. And let's see what we've got. So we're looking for 222 and 223. So there's 222, says it's reachable. There's 223, says it's reachable. What about my loopback? Well, here, notice I've got another problem. My loopback isn't showing up as being reachable. Well, it's showing up, but I can use load balancing to get to it. But notice I don't have a specific 172.16.5.5. Well, just for the sake of demonstration, let's see if we can't ping another address. So let's take an address off of R5 that I should be able to reach. So let's say show IP alias. And let's just pick one. Let's pick this one. 10.1.45.5. Let's go to R22 and see if we can hit that address. So ping. And notice I have reachability. In fact, trace route to 10.1.45.5, and let's see what path it goes through. Well, in this scenario, we can see that it went from R22 to 3, from 3, let's see here, 223 to 203. Give me just 1 second here. So that's 12, so it went down to cat 2, and then it went down to 5. So we can see that that all worked the way we wanted it to. But the thing is I still can't get to this loopback, 172.16.5.5. Well, let's entertain one more thing before we dive a little bit further into this. So let's take a look at show IP route, and let's look for that specific route of 45.5 that we used. Notice it's in my routing table, and it's telling me to use 2/1, which we saw that it went from R22 through 2/1 up to R3, and then it was able to be routed the rest of the way. Now, like I said, we've illustrated the situation whereby this system is not allowing me to reach the destination. And it's not allowing me to reach the destination because this idea of auto summary. Now, auto summarization is on by default, even if we're running version 2. It would seem kind of counterintuitive because I run version 2 so that I can support variable length subnet masks, but by virtue of the fact that by default I'm going to be operating in auto summarization, I'm not really going to be able to leverage that capability when it comes to prefixes that aren't going to be physically attached to me. So what we want to do right now is we're going to end this particular portion of our presentation, and then what we're going to do is we're going to entertain how we repair this or fix this problem through this idea of disabling auto summarization. So I'll see you guys in that presentation.